Good morning, everybody, and welcome to Design Day 2021. Hope your semesters have all been good and you were able to get a lot of work done on your projects. We are the Autonomous Smoke Mister team, composed of Ollie Bradstreet, Isaac Hansen, Joshua Jones, Dom Koenig, Sam LeCain, and Connor Weston. When smoking or cooking meats, they can usually become dry over the unusually long cooking times for smoking. To mitigate this problem, many cooks generally have to keep constant watch over their meat. This can prove inconvenient and problematic as cook times for smoking range from 4 to 20 hours in length. Using the autonomous smoke mister, this replaces the need to tend to these slow-cooked meats by automatically basting the surface of the meat in question to deliver a finished product that is tender, moist, and flavorful. Our team had a number of objectives that we wished to accomplish with the autonomous smoke mister. These included delivery of fluid to the meat, automatic operation, universal installation capability, ease of cleanliness, as well as cost to manufacture. In an ideal situation for our unit would be able to apply a thick syrup or a buttery solution onto the meat surface, dispersed over an excessively large area of the cooking surface. Automatic operation involved the user being able to set intervals of dispersion as well as the amount of dispersion after each interval. Universal installation meaning any grill or smoker that the user owned or that we encountered, we were able to install our unit onto it. Our unit should be very easy to disassemble and clean thoroughly between operations, and the cost to manufacture this should be well under $50. Our engineering analysis mostly focused on the power of the pump that we would need in order to move a very viscous fluid through the tube and into the grill surface. We made these calculations at a worst-case scenario based off of Bernoulli's equation, indicating that we had about a 4-foot high transition from a ground-level pumping station to the surface of the grill. The pump that our team chose to move liquid onto the surface of our meat for the autonomous smoke mister was a 12-volt diaphragm pump capable of 110 psi. Originally, our team had wanted to go with a 12-volt peristaltic pump due to its high degree of sanitation. However, after engineering calculations, we found that any peristaltic pump capable of producing the PSI requirements that were necessary for this project were well outside of our budget. As a consequence, we compromised with cleanliness and we decided to go with this 12-volt diaphragm pump, which only cost around $20. Used in conjunction with our 12-volt diaphragm pump is this 12-volt solenoid. With this solenoid in line of the fluid, we were able to control our dispersion amounts very effectively and enhance the overall usage of our device. The reservoir tank chosen by our team will allow the user to hold 6 quarts of their chosen liquid. Based off of our testing, as well as user interviews, we determined that an average of 3 ounces of liquid should be applied every 30 minutes. With 6 quarts of liquid at their disposal, the user should never run out of liquid during the basting process. The control board for our autonomous smoke mister utilized an off-the-shelf Arduino Uno unit. Paired with this Arduino unit was an Arduino dual relay board, which allowed for control of our solenoid. Settings on our control board included an automatic setting which the user could set and forget, the 2 potentiometers controlling dispersion amounts and intervals between dispersions, as well as a manual setting allowing the user to disperse liquid at their will at the press of a button. The current version of the housing for the autonomous smoke mister was 3D printed. This housing would be able to contain the pump, solenoid, applicable power supply, control board, and reservoir tank. While the control board, pump, solenoid, and power supply are firmly yet non-permanently fixed into the housing, the reservoir tank is easily accessible and can be slid out at any time for thorough cleaning. The tubing chosen by our team is a silicone polymer tubing with a temperature rating of 500 degrees Fahrenheit. This tubing was selected both for its ease of installation as well as its high temperature rating, as anticipated smoking temperatures will not exceed 300 degrees Fahrenheit during use. The nozzle selected by our team for the autonomous smoke mister was this 90-degree fan nozzle. It allowed for a fanned coverage of liquid over the entire surface of the meat. Our team decided that it would be beneficial as well to provide two nozzles mounted inside of the grill for even better coverage. An adjustable clip and mount system was also utilized for the autonomous smoke mister. One side would stay mounted to the grill grate, while the other would hold one of the nozzles securely in place. The bendable arm in the center allowed for a variety of positions to be achieved in order to coat a variety of different cook surfaces, such as chickens or turkeys, or even a flat brisket. Here we see a sample simulated video of the autonomous smoke mister in action. First, the user must turn it on the back panel with the on-off switch. The manual mode allows the user to distribute fluid, while the automatic mode, set with the two potentiometer commands, allows the unit to run automatically. As previously stated, the interval between dispersions, as well as the amount dispersed after each interval, can be tuned by the user for the optimal barbecuing experience. Manual mode can be achieved at any time by simply hitting the manual button. Whether basting your meat to stay moist during cooking or adding a little bit of flavor for the final product, the Autonomous Smoke Mister is the product for you. Thank you everybody for watching our presentation, and I hope that you enjoy the rest of Design Day.